Okay. Hi, Ani.
Hi, Janakiraman.
Yeah, so welcome back. So in the last week, we looked at, how we would actually take an analog signal and get it into a digital computer, right? We saw the Audacity software store some data and, you could even process it and all that. So I thought it was a good opportunity for us to just tear down a computer and look at what there is inside, a laptop or a desktop. So I just picked a laptop, the Lenovo T420.
Okay.
Okay, so I thought I'll just, discuss with you what the various parts are, what the usage is, and so on.
Absolutely.
Right?
Yeah.
So, So now we come to the more sort of the more internal parts that is not visible to a typical user, and this one is again.
Of course, I can see it says Li ion.
Yeah,
it's the battery.
It's the battery, lithium ion, and what does it say?
It says 4,400 milliampere hour.
Hour, right? And
Yes.
48 watt hour.
48 watt hour.
So this is something we have seen earlier with
That's
respect
right.
to mobile phones.
Yes.
Okay. So we must keep in mind that this is a rather old laptop. So 4400 milliamp hour was good for a laptop that time, but now it's barely enough for a phone.
For a phone.
Right?
That's right.
So
Interestingly, it also gives the voltage. It says DC 10.8 volts.
10.8 volts.
Yes.
Right. So so just like we saw on the small phone batteries.
Yes.
It's now a much bigger one, but and this just plugs in again into, you have the connections here.
Yes.
Right, and it plugs into the board somewhere there and it can be used, right? Yeah, so now we are left with, rather intricate parts.
Yes.
Okay, so let's start again from the bigger ones.
Okay.
So this one, what does it say?
Okay. So it says data storage, HL data storage, super multi DVD writer.
DVD writer,
Yeah.
right? So this is basically your DVD writer. So if you could press this,
It
and
would open up the tray.
You put a DVD, right? But nowadays I don't think there is a CD player or DVD player
I think,
at all.
Yes.
Right? It's all gone.
I think in another 10 years, people will not even know.
No.
It will be like a floppy disk.
Floppy disk of our times.
Yes,
Right?
that's
Exactly. So nobody will know this. But anyway, so it's a way of storing data. So we'll not spend too much time on this either, right? And of course, the next biggest thing obviously is the
yes,
keyboard.
the keyboard,
Right,
yes.
and there are a few other controls for volume control, the power, and all
yes.
that, right?
Yes.
And underneath, this would translate to pressing some sort of a button here,
Yes.
right? And you see that there is a cable that, so you can see this cable,
That's right.
right?
Yes.
This goes and plugs into the board again into some socket,
Okay.
right? And that's how all the communication from this keyboard goes there.
I see.
So if you press A, you know it's A because some signal
Is sent there.
gets in from here,
I see. Okay.
right?
Okay.
So again, it's a very compact, this thing. Now, I pulled out something very interesting from here, right? When I actually disassembled it, right? This part fits right here. Okay, if you look at it, or
Yes.
I think it fit like this.
Like
Yeah,
that.
this is
Okay,
exactly
I
how
see,
it
I see.
was.
Okay.
It fit exactly like this.
Okay.
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 And if you look at it,
And I see something rotating here. Okay. It's a
exactly,
fan. It's a
right?
fan.
It's a fan.
Ah.
Okay. So what the hell is a fan doing in a motherboard? Something that I have not been able to understand so easily, right? It is it's essentially some sort of a 5 volt. It says DC 5 volt 0.2 ampere fan.
Fan. I see.
Okay.
Okay.
Now, what are we trying to do with such a fan? And why would we need it at all?
Okay. So of course a fan helps to cool things down.
Okay.
That much we know.
Yeah.
Well, actually, in one of the previous classes, we talked about capacitors sharing charge and you lost energy somehow.
Yeah.
Right? Half the energy was gone, dissipated as in the as heat.
Heat.
So when
Exactly.
you're actually charging and discharging capacitors
Yeah.
to create zeros and ones,
Yes.
I'm assuming for VDD and ground,
Yeah.
you're going to lose energy
Heat.
as heat.
Right. So okay. So you're suggesting that things can get so hot that you need to cool it down like that?
Well, depends on the number of transistors or devices, switches, capacitors, whatever you have here.
Right. Okay. So that is very interesting, right? So essentially, you're saying that if you have just one capacitor charging,
Yes.
it's nothing. But if I have like a billion capacitors all charging together and each dissipating very small amounts of power,
Yes.
just the sheer number can make it a
Can make it very hot.
very hot,
Yeah.
right? So I think that is absolutely right. So this is the fundamental thing that's needed to cool the system.
Okay.
It seems like in this case, the heat is sort of being dissipated through this copper here and then
Okay.
is sort
I
of.
see, I see.
So if you look at the packaging also, you will find that black cover casing had a hole here.
Had a hole there to make
Yes.
sure that heat goes out.
Heat goes out and you would see that is sort of
Actually,
is
you're
very
right.
hot air.
See, I have seen in the old days when laptops used to be new.
Yeah.
They, even though they were called laptops, people would say don't keep it,
On the lap.
on the lap because
Exactly.
you can get burns.
Exactly.
Because at this outlet, it can be quite hot air, can be blowing all the time.
Exactly, right? So it's something. So what is it that is right underneath that is sort of so important that we are trying to cool? I mean, we don't seem to be cooling
That's right.
this part. We don't
Yes.
seem to be cooling the memory
true.
part, right?
That's
So
true.
okay, so can you pick that up? The largest part that we pulled out. So this. So what do you think this is?
This is of course the screen.
Of course,
right?
screen,
You open
right?
it up.
You open it up. So it's visible to the
Yes.
user also.
Okay.
So this is what, like some LCD display or
Yes.
something,
Yes, most likely
right?
yes.
So the fact, I mean, this is like effectively like a TV.
Yes,
So
correct.
you can see all that you need,
That's
and
right.
there are a couple of wires that connect to the that side.
I see the webcam here.
Yes. Oh, there is a webcam
Yes.
at this point.
That's right.
Interesting point. Yes.
Okay,
Right.
okay.
So yeah. So we are not going to discuss too much about the display technology. So let's keep that aside. Now, what we have remaining here is probably the heart of the computer.
Yes.
Right? The
Yes.
real heart of the
I
computer.
think you pretty much need everything here.
Yes.
For it to work.
For it to work.
Because I know, you have, I have heard of computers with servers where you don't need direct screen or a keyboard
Yes.
or a mouse to use.
Exactly.
And I don't need an optical drive.
Yeah.
But I need everything here.
Everything here. Yes,
Right?
exactly. So you could take off your monitor, you could take off your keyboard, everything, but you could have this still function as a computer, right? And you could control it remotely through some other means.
Some other means.
Yeah, so that's a very nice way of describing it. With you remove any one component from here and your computer will not function.
That's right.
Right? Great. Okay. So what we see here is, it's what do we call this board?
This board is called the motherboard.
The motherboard.
Right. I have seen it. I assume they call it the motherboard because other things plug into it. It's the largest.
Yes.
Right. Other things plug into it. I
Yes.
think.
Okay. So this is called the motherboard, right? So let me just write that down here. Okay. And let's see, what seems to be there on this motherboard. Okay. Again, there are some wires. Okay. So what is this?
Okay. That looks very much like I can see. I know it's yes.
Right.
It sticks. Yes, of course.
It sticks. It has a magnet,
Yes.
and therefore it has to be the
speaker.
right?
Yeah.
So that is something we saw, and correspondingly, there is also this guy.
Oh,
It
okay.
seems
That's
to
a
be the-
classic 3.5 mm connector for audio.
The audio jack.
Audio
right?
jack.
So in that experiment where we, try to record with Audacity, I plugged it into one such jack.
okay.
Right? My
Yes.
headphones were
Yes.
plugged into one such
One of
jack,
those.
and that is sort of connecting to the board here, right? In fact, all this connects through some sort of a cable.
Oh, I see. So it's just a plug-in
It's
cable.
just a plug-in cable. You can even plug it back if you need, right? Okay.
Okay.
And that's your audio jack. So somewhere on this board is that ADC,
Yes, that's
that we
right.
saw.
It has to be.
right?
Correct.
So let me again put that here, right? You have your audio jack, okay, 3.5 mm, okay, some sort of a cable like this. It's getting in, and then on this motherboard,
Yes.
we have an ADC. So this ADC is very tricky to spot on the motherboard because
Yes.
it could be in the processor or it could be a separate chip. It doesn't matter. The sound card as such can be sort of quite hidden somewhere in this motherboard. So we'll not worry about identifying the ADC,
ADC
as such.
Yes.
Right? We'll just focus on the other components. Okay. So you have an ADC, and then of course that goes to the speaker eventually and all
Yes.
that. Right? Then what else do we have? So what is this component? This seems very interesting.
Interesting. So,
So first of all, it looks like this will come out.
yes, I think it will. Oh, okay. Yes. Perfect. Yeah.
So, okay. So what is this?
Okay. It says DIMM.
MM, right?
Right.
So should we do a Google search
Yes,
and just
let's
figure
do
out
that.
what that thing is? What is a DIMM?
Yes.
Maybe useful to do that, right? So let's just.
I think it used to be. I have heard this before.
Yeah.
I think it's some dual inline module,
Yeah.
something like that.
DIMM computer,
Yes.
right?
Is it that? Dual inline memory
Dual
module.
inline memory module. So
Ah,
let's see
okay.
what this is. Okay. So so it seems okay. So before understanding about DIMM, it's good to have information regarding RAMs. Okay. So what is a RAM? So let's
Okay.
put that down. Okay?
Yes. Yes.
Let's put that down. So we have something called a DIMM.
Yes.
Okay. Dual inline memory module. Okay. And it seems to talk about something called a RAM.
Yes.
Okay. And what is RAM? The RAM is nothing but random access memory.
Perfect. Yeah.
Okay. So memory is something that stores data, right?
Yes.
So we had earlier alluded to the capacitor, whether it could be an analog memory, but you said that it would leak away and all that. But very interestingly, if that capacitor is sort of refreshed often enough, you could use it as a memory.
That's true.
Right?
Yes.
And it turns out that is what people call a dynamic random access memory.
Dynamic,
So they
RAM.
call it a DRAM. It's just a capacitor that's storing a voltage. If it stores high voltage VDD, it's a logic 1, otherwise it's a logic 0.
Logic 0.
The logic 1 will keep losing charge, but you refresh often enough, right? So this is DRAM, which is basically dynamic RAM. Okay, there's also something called static RAM,
Okay.
but that will it comes inside the processor.
Inside
You cannot
the
see it on the motherboard so easily. Anyway, so what we have here is like a bunch of ICs,
yes.
and each of them is a DRAM chip.
Is a DRAM chip.
Okay,
Yes.
and
So I do see some writings on it.
Yeah.
So it says 4 GB. So I'm assuming that
so you're saying it has a
it says 4 GB here.
okay, very good.
Okay.
So this is
It's some brand, but some company brand, but it says 4 GB.
4 GB.
Yes.
Okay, great. So
Okay.
so there is in some form there is
Yes.
4 GB of memory that is available. Okay, and each bit is either a logic 1 or a logic 0, right?
Correct.
So that's what we call a bit.
And it says 2R into 8. I assume it's 2 rows into 8.
Yeah,
Right?
exactly.
8 of them.
Yeah.
And so on. Okay.
Exactly,
Great.
right?
Great.
So it's essentially each DRAM chip might be smaller, but you put all of these
put all
together,
of
you
these
get
together. Correct.
big memory.
Correct.
Right? So maybe we can start writing some sort of a block diagram. Okay, so I have the DRAM memory, okay, which is in the form of a DIMM.
Yes.
Okay, and I also have my audio jack going to the ADC.
Yes.
Okay, 3.5 jack. Okay, where all these goes, we'll
Yes.
figure out in
Yes.
some time.
And we
Okay.
have the keyboard, writer, etc. But that's
Yeah, all those are
peripherals, right?
peripherals. We'll not worry about that.
Okay.
Okay. So now, what else do you think will sit on this motherboard?
Let me look for the next biggest one.
Yeah.
It's probably this guy here.
Yes.
Okay.
So can you take that off?
Let me take that off. Oh wow. Okay. Okay. This looks like actually like a bunch of pins.
Bunch of pins.
I don't know if it comes across on the camera very easily.
Yeah.
But it's basically just a bunch of pins.
Okay.
Standing
And this
out.
technology, you know what this technology is called? What that they?
Okay. So some kind of, so it looks like, so they seem to be plugging directly into these slots here.
Slots.
Right? And it looks like I'm kind of flipping it over somehow.
Okay.
So some kind of
Flipped. Okay.
Okay. And this seems to have some electronics on it,
Yeah.
both there and here. Some kind of flipped
Flip chip
flip chip maybe.
bonding is what
Yes.
Google seems to suggest.
Okay. Flip chip
So
packet.
let's
flip
see
chip
what
bonding.
it says here. Okay.
Okay.
So if-
Interesting. Actually, it does look similar from the top at least.
yeah. Okay.
Right? When I look at the original circuit,
Exactly.
it looks like what the chip looks, right?
So you seem to
Yes.
have some sort of a ball array kind of thing.
Absolutely.
And you
correct.
flip it and you just
You
connect
plug
it.
in. Okay.
Right?
Right.
So, okay.
Interesting.
Finally, there's one important part which seems to be this.
Ah, okay.
So what is this?
It says Toshiba disk drive.
Disk drive.
Disk drive is
Okay.
what it says.
Okay. And any other technical specification?
DC plus 5 volts, 1 ampere.
Okay.
Okay, plus 5 volts, 1 ampere.
Yeah.
And I see 320 GB.
GB. Okay. So 320. So what was this DRAM, by the way? You said 4 GB.
4 GB. That's
Okay.
right.
And then you seem to have something. I'll just draw it to scale.
Yes. Much larger, right?
Much bigger, right?
Like about 100 times? 80 times
80
bigger.
times the
80
size.
times bigger, right?
320 GB.
Yes.
Okay. So this seems to be some sort of a memory again.
Yes.
Okay. This is memory. Okay.
Yes.
And the memory size is like 320 GB.
Yes.
And okay, what does it? There's something else.
Okay.
5,400
100 RPM.
What is this?
Okay. Yes, that is true. It does say 5,400 RPM. RPM, I know revolutions per minute, because when we discussed frequency, we talked about so many revolutions per minute.
Revolutions
so that's
per
what
minute.
I know. Correct.
So if that were the case, there's something rotating inside,
See, must be.
and it's a mechanical rotation,
It must be a mechanical rotation.
right?
Right.
So yeah, so we'll open this up and check later.
Sure.
But
In fact, it says, because it says disk drive,
Yes.
I'm assuming that something must be
motor drive is there. Some
must
motor
be
drive is
something
there,
must
right?
be moving.
So so my question is, if you look at, if we had done the same thing, a deep dive analysis into the architecture of a mobile phone, we would have seen something very similar.
We would have seen something very similar. So I'm sure there will be a processor, there will be a
Processor, there's a Wi-Fi unit,
There's
we
a
have a
Wi-Fi
Wi-Fi
unit.
there, we have a
Yes.
Bluetooth thing,
Correct, that's
we have
right.
the audio jack,
But I've
right?
never heard of a hard disk drive.
hard disk drive, right? So for example, so what would you think? So you might have a DRAM also,
Yes, I'm
right?
sure you'll
Absolutely,
have a
you'll have a DRAM, right?
Yes.
But this, so let's look at the phone specifications,
Yes.
right? You buy a phone with like 128 GB,
Yes.
64 GB.
Actually, yes, that's right. So there are 2 GBs there
Yeah.
when you buy a phone.
Yeah.
So if you buy the latest phone, for example, it says 8 GB RAM
Yeah.
and it says 256 GB storage.
Exactly. So
Right.
that 8 GB is actually this RAM, this DRAM is what we are talking about. So you have, this is a 4 GB RAM with a 320 GB hard disk.
Hard disk or
Okay.
storage. Storage.
Yeah,
That's
storage, right? On the other hand, the phone could be 8 GB RAM,
it. Yes.
okay, with let's say 128
Yes.
GB hard disk, right?
Yeah.
Storage. yeah.
Storage is what they say, I
Yeah.
guess, in phones.
Okay, but so look at this guy.
Yes.
It's quite bulky.
It's quite bulky. It looks almost as large as the
phone, exactly, right? So there's
So
no way that
gonna
someone
fit
could have
something
put,
into
right?
this.
Now,
Correct.
what is the difference then? How did they get 128 GB? Because it's not just 128. We know phones with 512 GB,
512 GB,
which is
that's
bigger than this.
That's right.
Actually, right? The memory size is bigger.
Absolutely.
So, what is it that has allowed people to put in such storage?
So the only thing I can imagine is like miniaturization in the form of an IC again.
IC again, right?
Even for,
so and
memory.
also this 5400 RPM
Yes, you also need space and power and everything for,
for
moving the
something to rotate, right?
That's
So in
right.
fact, when you open this up, we will see that rotating part is, the head is actually easily visible. It's a huge part.
Yes,
right?
that's right.
So you cannot have like a 320 GB 5400 RPM disk sitting in a mobile.
Of course.
That has to be some other technology, right?
Of course, people also move around their mobiles a lot. I can't imagine, you know,
right?
having a moving part.
In
very
fact,
easily visible.
this hard disk is actually quite susceptible to errors. If you leave it for some time and don't take care of it properly, it could easily get damaged, right? So this 128 GB, right? If you look at a phone, right, is typically what they call the SSD
Yes.
memory,
Yes.
right? SSD storage.
In fact, I have heard of new laptops. The more expensive laptops, they say instead of hard disk, they say SSD.
SSD, right?
Yes.
So in fact, if you look at the time it takes for the operating system to boot on a hard disk like this,
Yes.
as opposed to an SSD, it is at least 8 or 10 times faster, right? And
Yes.
that is, so this is basically called solid state drives.
I see. Okay.
And solid state refers to, transistors and miniaturization, like you said,
That's
in
right.
ICs.
That's right.
No mechanical parts. It's just how fast can you charge a capacitor.
Yes. And
Essentially,
we know that can
right?
be, you can.
That can go down to like really quick times. If the capacitor
Yes.
is small enough, like femtofarads, you can do this in the order of nanoseconds.
Nanoseconds.
Right? And therefore, this is going to be like really fast, right? And much faster than such things. So that's why your mobile phone is actually very responsive also. It's
Yes.
not, it doesn't
Doesn't
take
seem as slow as
a
even
laptop,
yes,
right?
that's
As a
right.
laptop. So therefore, this sort of the external storage, right? This is sort of the external, right? In fact, if you observe the packaging of this guy,
Yes.
this was easily removable, right? It was easily removable and replaceable with something else if needed.
I see. Okay.
Likewise, this DIMM
Yes.
is also replaceable very easily,
I see. Okay.
right? And in fact, in some computers, you will see multiple slots.
Yes.
Right?
I have seen in desktop computers. I have seen it.
They are called these PCI slots where you can just keep adding your DIMM and
That's
increasing the RAM. Okay. So therefore, this one, if you remember the dismantling, would come out on the other side. You just open it, you will get this guy out. Right? You can replace it, increase your RAM. You can increase the hard disk. But the motherboard and these parts are not accessible because you don't
Normally
play
you
around
don't
with
touch,
that,
touch
right?
the rest of the things.
Exactly. So, and in fact, if something goes wrong, you would have heard this guy in the store tell you, sir, it's a motherboard problem.
Yes.
You have to replace the
You
whole
have to
thing.
replace the motherboard.
Right?
Yes.
Because you can't pull this out
Correct.
and actually solder something back
Yes.
in there.
Yes.
Right? So, essentially, this is what we have. We have the DRAM that can sort of, talk to the
Yes.
hard disk and back, right? So, if you look at the microprocessor, it has, like we said, 2 levels of memory, right? So it has 2 levels of memory because this memory access time will be something of the order of 30 nanoseconds, whereas this will be of the order of what? What do you expect?
Probably microseconds. Maybe
Micro-
even
milli.
if it's a this thing, it's probably going to be milliseconds.
It's a mechanical part,
Mechanical part.
right?
So
So
probably milliseconds.
This can
Let us say
operate
10 milliseconds.
Yeah, in
Yes.
about 10 milliseconds. So,
Makes sense.
So the microprocessor, let's say you want to add 2 numbers. Okay, let's just deal with 1 and 0. I want to add 1 plus 0, right? The microprocessor can do the addition for you.
Yes.
But where do you get these numbers from?
Correct. They have to come from some storage.
Exactly, right? So you store them as 1, 0.
Yes. Of
Okay.
course.
Then the microprocessor will fetch the 1, fetch the 0, do the addition and send the answer back. Now, of course, 1 and 0 is very simple, but what if it was like what we saw in the wave file, a huge file that could run into MBs,
Yes.
right? You may not be, or let's say more than 8 GB, 4 GB.
Yes.
You
Yes.
cannot store everything on this, right?
Correct.
So then you need to come here, right? So the memory, the external storage will allow you to store large files, but will have large access times as well, right? The internal memories, the DIMM, has much smaller access time, but much smaller memory.
Much smaller
So
memory as
the microprocessor needs to manage what sits in this DRAM, what sits in the hard disk,
Sure.
right? And in fact, what is not shown to us here, not evident, is there is a memory inside here.
Inside here as well, I'm sure.
Else, right? This is called the L1, L2 cache kind of memory,
Cache memory.
where you can store something very quickly, get it back, but it's very small. It's like 128 bytes.
Actually, if we search for Intel microprocessor, let us
Yes.
say this is an Intel,
Yes.
you might actually see those specifications for the
I
processor.
think that's a good idea, right? So Intel.
Well, we don't know the part number for this, unfortunately, because it's not written.
We know Pentium, right?
Pentium, yes.
Right? Pentium.
In fact, I think maybe people
4.
will know i9,
i9,
sorry, i7 or i5, they will know.
i7.
Yeah. Okay, there is a Core i7, some let's say this one, desktop processor.
Okay.
Yes.
It says Intel processor speed is 3.6 gigahertz.
I see watts, by the way, the 125 watts.
Watts.
So the processor is taking power of the order of
Watts.
100 watts.
Watts, right?
50 to
And
100
that's why
watts.
you needed
Amazing.
this fan.
That's why you need the fan. Now I see
Exactly, right?
it. Right? Okay.
Okay.
And let me see here. Maybe we should go to the maybe the Intel website instead of the Amazon website.
Yeah, Intel website, right? Maybe we should do that. Okay.
Yes, I think here I see an Intel processor specifications.
Yes. What? 8 MB smart cache.
okay.
Seems to suggest something like that. And what is this? We have some TDP and stuff like that.
Yes.
Just let's look at one of
we
these
can look
guys,
at any one
anything,
processor.
right? Any one of them, right?
Yes.
Yes.
See something here.
Here,
3
right?
MB and
Yeah.
32 GB.
32 GB.
Interesting.
Okay, depend on
Yes.
memory type. We are looking at the internal memory.
That is up there. So can you go up? I see something here. Is this the one?
3 MB. What is this?
Yes.
Cache.
Located on
Cache
the
is an area of fast memory located on the processor.
Yes.
Okay, that allows all cores to dynamically share. So effectively, exactly. So we have like, where is this? We got 3 MB.
3 MB.
So 3 MB, right? You see
Yes.
the orders of difference,
It's
right?
about 1,000 times smaller.
Yeah, MB is 10 power 6 mega.
Yes, mega.
Giga is 10 power 9, and
So that was 4 GB. This is 3 MB.
3 MB,
So
right?
it's- yeah.
Clear orders of magnitude difference,
Yeah.
and then the hard disk is 80 times,
80 times that.
right? Or even much
Yeah.
larger than that, right? So
And I can see
effectively-
from the relative sizes as well. So
Yeah.
I guess
What's that guy then? What is that chip?
these are, the processor is so much smaller,
Yeah.
right? The memory is next bigger, and the of course the hard disk
Hard
seems
disk
a lot
is,
bigger.
is the biggest thing. Yeah, but SSD can be quite misleading.
SSD can be quite exactly.
Misleading.
That's
It's
right.
not size does not mean the
Size. That's true.
memory
That is
size.
because you do get 256 GB sticks which are so small.
Exactly.
Right?
So I mean in the laptop you might see that the SSD also is of a similar form factor, but that is to only make it compatible to this,
Correct.
right?
Correct.
The inside the chip will be much smaller.
Much smaller.
Much smaller, right?
Makes sense, yeah.
Exactly. So essentially what now we want to do, understand going forward in this week is, okay, you have a microprocessor, you have a memory, you have a hard disk, and you have all these peripherals. So how did the analog signal come in and sit in this
Yes.
memory here as a wave file?
Yes.
Cool. The Audacity said, no, this is a wave file. We were able to store it, we were able to open it, retrieve it, process it, and do something with it, right? We want to figure out how this analog signal here actually eventually came into this memory here,
Yeah.
right? And we already saw that the ADC gave us a discrete time, discrete amplitude signal.
Yes.
But we are still, that means we were able to take this signal and convert it into a sequence of integers.
Integers, correct.
0, 1, 1, 10, 22, 33, and so on.
Yes.
But I still don't know how to store all of that in this, right? Okay, so we have the hard disk, as you can see here.
Yes.
I've opened the lid, right? It was covered like this. I just took the lid off, and what we see here is something very interesting, right? So what are the moving parts? Let's look at it. Looks like this
Okay.
can move.
Yes.
Okay. This can move a little bit like this, and
Does that thing rotate, that circular disc?
can you try? I mean,
Yeah.
I'm going to put my hand on it, which
Sure.
means the data is gone.
Data's gone.
Hard disk is gone. Never do this, but
Yeah. Oh yeah.
Yes.
Okay. So it moves.
it seems to rotate.
Okay.
Okay, so this is probably why it was called a hard disk drive
Hard
that
disk
you mentioned.
drive, exactly,
Right?
right.
So what I will do is I will just take off a couple of more screws, okay, so that we can observe and appreciate this a little more. Okay, I'll use the right screwdriver now, and let me. Okay, I'm going to take this off so that we see that this part can actually move all the way now.
So it's almost like a scissor with around the
Exactly,
Right. It
right.
can read both sides, maybe.
Maybe,
I
exactly.
wonder,
Right.
okay.
Now I will also take the other screw, the center screw off. Maybe the disc will come off. I don't
Okay,
know.
okay.
Let's try. So I've got this off, and let's see if this disc. Yes.
Okay,
The
nice.
whole disc has come off, and what we see.
Okay.
Is-
It's just the what spindle, I guess you
Yeah,
could call it.
spindle, and this is what is controlled by the motor,
By the motor.
right?
Yes, that's
and the
right.
5400 RPM
Is the rate at which it rotates.
at which this motor can rotate.
Correct. So that rotates and causes this disc to rotate,
Yes.
right? And this head basically stationary. It just goes in,
Exactly.
right?
Right. Right.
And if I remember right,
Yeah.
I vaguely remember that the information is stored somewhat concentric
Circles or something,
circles,
right? So,
right,
okay, yeah.
around this. So the head kind of moves
Yeah.
from the periphery of the disk to the center.
Okay.
It can read different parts of the disk.
It can read different. So
While
this,
it's rotating.
So you're saying this will move here.
That's right. It can move.
It can read different parts.
Yes,
And
while it's
because the disk is rotating, it reads different portions of the
That's right.
of that circle, right?
So basically, together with the rotation and the head movement,
Okay.
you can read every square micron of this
disk, right?
That's right.
Okay, so that's excellent. So, so fundamentally, the very fact that we are able to see it with our eyes, right? It's
Yes.
a huge part. There is this weighs a couple of grams,
That's
right?
right.
And
Yeah.
and you're trying to rotate it with a motor, means it has to be pretty slow.
Yes.
Okay, in what scale compared to the scale of electronics, right? If you compare how fast you can charge a capacitor and discharge, this is going to be slow, and that's why the discussion on SSD, solid state drives.
That's right. We saw that the hard disk, the latency for getting data is like a few milliseconds.
Exactly,
Right?
right?
So,
Exactly. So this is the fundamental reason for why things are very slow in a traditional hard drive, right? And nowadays we overcome this, right? In fact, the size of an SSD,
Yes.
what do you reckon will be like the size of this?
Probably the size of that.
Right, the size of this
Yeah.
chip here.
Yeah.
That's all. And for the same 128 GB or 350 GB, it
Yes.
might be something as
Something
small
like
as
that, as small as that.
this, right? So in this week, we will look at how we can take this discrete amplitude signal and convert it to a digital signal. Okay,
Great.
thank you.